Today we're looking at Example 4 out of Section 3.3 Local Linearity of Business Calculus with Excel. We're looking for a linear approximation of f of x equals e to the x. And as always, our linear approximation is f of our base point plus f prime of our base point times the distance from x to our base point. So we'll need to evaluate f of 0 and f prime of 0 and use these results to approximate the values when x is near 0. We'll want to see how close our answers are to the correct answer. More importantly, we're going to want to know for what domain is our approximation within 1%, because the linear function, once we have these two coefficients, is going to be easier to compute than e to the x is to compute, and we'd like to know when we can just use the linear approximation and not have to do exponential functions. We're using, if we look at the top part of this, the same template we've been using, and notice where everything is set up, and if I compare it to the previous examples, it's pretty much character for character the same thing, except I have a different f of x and a different x naught. But everything else, what f of x is and what x naught is, everything else is character for character the same thing. So again, my numeric derivative, I want to evaluate the function at x naught plus 0.01 and x naught minus 0.01, evaluate the function at those 2 points, take the difference, divide by 0.002, that'll give me the numeric derivative. Once I have that, I can plug it in and make a chart, and I'm interested in my chart the value of f of x, the correct value, the linear approximation, the error, and the percentage error. I can take this, I show my formulas, as opposed to we're used to seeing these errors be less than 0.01%, I'm getting some pretty large errors here. The explanation is if I look at the exponential function and its tangent line, they don't stay close together very long. And what I want to know is how big a region here can I say the function and the derivative are about the same. So clearly, minus 4 to 4, 1 plus x isn't a good approximation, but I'd like to know for what region is the approximation good. I'm going to look at my formulas again and see I've worked out f of x, the linear function, the error, but now I'm going up by b $7, so a delta x. I had started with 1. I fill out my table, I unshow the formulas, and my percentage error is getting too big if 1 is my answer. So I'm going to then say, why don't I make 0.1 my definition? 0.1, it's still too big. I'm up to 19%, but it's in the right direction. I'm going to try 0.01. I'm down to 0.3% of the error, so I'm under 1% error. I'm going to look at equals 0.02, and what I can see is up to 0.14, I'm under 1% error. So my result is that I can approximate e to the x by 1 plus x if my rate is from 0 to 15%. That gives me an easier valuation rather than using exponential functions. Thank you.